Okay, welcome to a lesson on exercise 6C, graphing straight lines. Yesterday, we learned that a graph of a straight line represents a relationship between two variables. So let me just pull out my pen. So if you have something like this, and you have a straight line graph, and this might be, I don't know, time in years, and that might be your height in height in centimeters, for example. So ignore that. And there, that might be T, that might be H, and you have a line. Now, a straight line represents a relationship between time and height. So we did this yesterday. Now, what if you have a relationship in algebraic form? What if you have something like, height is equal to time in years multiplied by, I don't know, I'm just gonna make something up. So let's say 21H. What happens there? How do you graph that? I guess that's the question. So that's what we're gonna learn today. How do you graph a relationship that has been given in algebraic form? Oops, that should have been T, not H. Height is 21T. Anyway, moving on. For example, let's say you're at the canteen, you're buying ice cream. Ice cream costs $2 each, let's say. Then we are going to say let y equal to the number of money I will pay. Now, y could be anything. It's a variable. It could be anything. We chose y at random because why not? So y equals the total amount of money I will pay. And let x equal the number of ice creams I will purchase. Now, clearly, there's a relation between x and y. Because if you buy 2 ice creams, you're going to pay $4. If you buy 5 ice creams, you'll pay $10. So clearly, there's a relationship between the total amount of money I pay and the number of ice creams I purchase. The more ice creams I purchase, the more money I will pay. Specifically, it's $2 each, right? Now let's look at that in terms of algebra. That's a lot of words. We've set up the variables y and x, and we can say y dollars is equal to $2 times x. So the total amount of money I will pay is going to equal to $2 times x, where x is the number of ice creams I purchase. So if you purchase 10 ice creams, you sub 10 in. 2 times 10, $20, and that will give you y. We can write that more simply, just y is equal to 2x, and that would be the algebraic relationship. Now, in order to graph this, the most basic way to graph is to just do a table of values. And all that means is, I'm sure you've done this before, a table of values looks something like this. And then you have x and then y, and you have a bunch of numbers here, 1, 2, 3, 4, 5, and you have to figure out what y is, okay? So you figure out various values of x and y, and you make a table out of it, which looks like that. That's a table of values. And that's, we're going to learn how to do that in a second, but that's just a table of values. And that's probably the most basic way to draw a graph. It's somewhat similar to trial and error because you are just picking values of X and you're just finding out what the values of Y are. And then you just plot them in. So it's kind of like trial and error. But that's okay. It's perfectly valid. It's a perfectly valid way to do it. In fact, if you end up doing Maths Standard in year 11, year 12, this is going to be the main way. If you do Maths Advanced, you probably learn a few more advanced techniques. But yeah, this is the basic way. This is the stock standard way. Moving on. So let's continue it. Let's continue our ice cream example. How much do I pay for 1 ice cream, 2 ice creams, 3 ice creams? And that's what we're going to be doing. We're going to be filling the table of values. If x is 0, how much do I pay? X is the number of ice creams I will purchase. So if x is the number of ice creams I purchase, if I purchase 0 ice creams, how much money do I pay? Well, I pay $0. What if I purchase 1 ice cream? Well, it was $2 each. I can just sub this 1. X is equal to 1. See how note this is the X row. X equals to 1. I can make that 1. 2 times 1 is 2. So Y is going to equal to 2. So I can write 2 here. What about if x was 2? Then you'll have y is equal to 2 times 2 because I'm subbing in x equals to 2 into the equation. And so y is equal to 2 times 2, which is 4. So y will equal to $4. And if x is equal to 3, Well, I'm just going to sub in 3. Y is equal to 2 times 3. Notice this is the original equation. This is the equation. Y equals 2x. I'm just subbing in values of x. I'm replacing x with these numbers over there. So at the moment, I'm subbing in 3. So y, when x equals 3, y equals to 6. Equals to 6. And when x equals to 4, what do you think the y value will be? And 2 times 4 is 8. Because when you buy 4 ice creams, how much money do you pay? You pay $8. And so we now have a table of values. We can, we've filled in the table of values, and now we can start graphing this. So how do you graph it? So the way you graph it is, you say x and y, that's the table of values. I'm going to say this is going to be x, and this is going to be y. And these arrows and putting the X and the Y, these are important parts of drawing a graph, which are often overlooked by students, but you do have to do it. You do have to draw the arrow, write X there, write Y there, draw the other there. You should have a heading as well. And total money paid at the canteen. Okay, total money paid at the canteen. Excuse me. And now we can start. I'm going to draw my 0, 1, 2, 3, 4. So 0 is over there. Obviously, 0 is there. 1, 2, 3, 4. And I can put 5 and 6 in because why not? 1, 2, 3, 4, 5, 6. And over here, okay, I should mention this as well because one of the advanced math students from last year made this mistake and Mr. Zuki got upset with me. If you do 1, 2, 3, 4, 5, 6, notice that it's going up by 1. Then you have to keep going up by 1 all the way till the end. You can't do 1, 2, 3, 4, and then suddenly do 10 and then do 15, 20. You can't do that. If you're going up by 1, 1, 2, 3, 4, you have to do 5, 6. Like you have to keep going up by 1. And same thing over here. I'm going to go up by 2 now. 2, 4. I can't suddenly just write 10 there. That's completely and utterly wrong. 100% wrong. You can't do that. If you decide to go up by 2s, you have to keep going up by 2s. 2, 4, 6, 8, 10, 12, 14. Okay, so it's very important that you understand that if you decide on a scale for one of your axes, so your x-axis or your y-axis, and you decide on a scale, you decide to go up by 2s, by 100s, by 5s, whatever you decide to go up by, stick to it. Okay, and you always have to start at 0. Yes, just always start at 0. If you ever have to do a very special graph where you don't start at 0, we'll let you know. But as a general rule, 99.9% of the time, you must start from 0 and then you must go up, in equal intervals. 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 3, 6, 9, 12, 15, and so on. Okay, please don't underestimate that. It's very, very important. All right, now I can start drawing. I can start plotting my values, and I'm gonna get a red pen. So when x is 0, y is 0. So when x is 0, y is 0, I'm gonna put a dot there. When x is 1, y is 2. Notice x is the top row, y is the bottom row. So when x is 1, y is 2. So when x is 1, y is 2, and that's going to be a dot there. When x is 2, y is 4. When x is 2, y is 4. And I put a dot there. When x is 3, y is 6. So when x is 3, y is 6, and I put a dot there as well. When x is 4, y is 8. So when x is 4, y is 8, and I put a dot there. And I can now join the dots to get my graph. So I get a ruler and basically I join them up. And that's how you draw a curve. That's how you draw a straight line. If you have y is equal to 2x, you can have absolutely anything, and that's how you do it. You draw a table of values first, and then from the table of values, just plot the points in, and there you have it. So let's look at some worked examples. Let's have a look at some of the questions in the book. It says plot the graph of y is equal to 2x minus 1 by first completing the table of values. And so what you would do is, 1 second, I'm just going to open up my calculator. All right, so I'll share my window. I really hope that did not stop the recording. Anyway, that's my calculator. And it says plot the graph of y is equal to 2x minus 1 by first completing the table of values. And so x is equal to -1. Now what I'm going to do is y is equal to 2 minus 1, 2x minus 1. Now in place of x, I'm going to put -1, then I'm going to put 0, then I'm going to put 1. Let's start off by putting -1 there. So 2. Sorry about that. My son just walked in. So 2, open bracket, -1, close bracket, -1. And -3. So y is equal to -3. If I put in -1 here, y is going to equal to -3. -3.
Wait, sir,
All right.
sir,
Yes.
where'd you get the -1 from?
Okay, so -1 I got from here. When x is -1, y is -3. I subbed in place of x, you know, it's 2x minus 1.
Yeah.
In place of x, I put the -1. Now, now y is equal to 2x minus 1. Because I'm doing this now, I'm going to put 0. In place of x, I'm going to put 0. So y is equal to 2, open bracket, 0 minus 1. And that's equal to, and you can use a calculator if you're not sure. You can just do it mentally. 2 times 0 is 0. 0 minus 1 is -1. So -1. Y is equal to -1. And therefore, I'm going to write -1 there now. And now, very similarly, now that I'm doing the last column, now x is equal to 1. So when you have y is equal to, hang on. So when you have y is equal to 2, x, well, x over here is 1. So I'm going to place 1 now, -1. Which is equal to 2 times 1 is 2. 2 minus 1 is 1. So y is equal to 1. Now that I've got my table of values, I can start drawing my graph. So I'm going to draw a graph like this, and then I will do -1, 0, 1. You know, I'm going to leave it there for the time being. Now for y-axis, I will need from -3 to 1 at the minimum. So -1, -2, -3. And make sure I'm drawing those. I'm writing the x and I'm writing the y. And I will need over here 1 as well. And so let's start plotting in the points with a red pen. So you have when x is -1, when x is -1, y is -3. So when x is -1, I'm going on the x-axis, I'm looking at -1. And then on the y-axis, I find -3, which is there. And I probably should have marked just so no one gets confused. That's -1, that's -2, that's -3, and that's 1. So, all right. So I've put a dot using the information in the first column. Now let's look at the second column. When x is 0, y is -1. When x is 0, that's going to be here. Y is -1, so I put a dot there. And now look at the last column. When x is 1, on the x-axis, where is 1? 1 is over here. And then y is going to equal to 1, so I put a dot there. And now, as before, I can use a ruler. Using a ruler will actually help a lot. And yes, so my one just snaps, I'm not sure why. But anyway, there you have it. Let's have a look at another example. Jasmine is organizing a school dance. The venue is chosen and the costs are shown in the table. And they've given you a table of values. It says plot a graph of the total cost against the number of students. So total cost against the number of students. And so it starts at 0. So I'm going to draw a graph like this. And students will go over here. Costs will go over there. As a general rule, one of these two variables is going to be the thing that decides the other one. Okay, so we call that dependent and independent. So over here, the cost is going to be decided by the number of students. So C is dependent on A. C depends on S. Not A, sorry, S. C is dependent on S. S is independent. C is dependent. Another way you can think of it is X, Y. And where does X, Y axis happen? X is over here normally. Y is over there normally. And so where X normally is, I'm going to put S. And as you can see, I've put an S there. And where Y normally is, I'm going to put a C. So I'll put a C there. All right, now you always start at 0. And then you write, let's say 100, 200, 300. 0, 100, 200, 300, 0, 100, 200, 300. It doesn't matter what numbers go over here, as long as you're consistent. Notice I'm going up by 100. 0 goes to 100, then going up another 100, going up by another 100, and that's perfectly fine. Just be consistent. You can choose the most appropriate scale as long as you're consistent. If you're going to go up by 5s, keep going up by 5s. But over here, I'm going up by 100, so I'm going to keep going up by 100s. Now, if you look at the second row, then what should we go up by, do you think? Anyone can answer, I don't mind. If you have something to say, just shout out. How much should we go up? Yeah, let's go up by 500. So 500. Maybe consistent. I'm not going to draw 1,000 there, right? If roughly the same distance. If you use a ruler, you can use every 1 centimeter, go up by a certain amount. So 500, 1,000, and unfortunately, I don't really have a ruler in OneNote. And over here, I'm going to make it 2,000. Okay, now using a red pen. You should also use a red pen when you do your own working. Let's plot those in. We look at the first column. When S is 0, C is 500. When S is 0, C is 500, I put a dot there. Okay, these you can think of them as coordinates. They literally are coordinates. 100, 1,000. And that's what they're telling you. The X coordinate is 100. The Y coordinate is 1,000. So how do you plot 100, 1,000? You go to 100, then you go to 1,000. And that's how you plot it. And this one is 200, 1,500. So 200, 1,500 will be around over there. And then you have 300, 1,000, 2,000, 300, 2,000. And there you have it. So while you're doing this chapter, all the graphs you get will be straight lines. And then you join up the dots. So there you go. Okay. Use the graph to determine the total cost for 150 students. Let's do a different colored pen. 150 students, roughly around over there. Oops. 150 students is around over there. And I'm going to use a straight line. You can use a ruler as well. You should be using a ruler. And then at a guess, I would say 1,250. Total cost will be 1,250. Because roughly it's around halfway between 1,000 and 1,500. Okay, it says how many students could attend the dance. And by the way, this is very similar to the previous exercise. So once you've drawn the graph, these questions are basically a repeat of everything that we did in the last exercise. How many students could attend the dance if Jasmine has a budget of $1,750 to spend? Well, whoops. $1,750, keep using green pen. $1,750 is going to roughly around over there. And let's say around there. Another line, draw a line straight down, and we can guess around 250. 250 would be our answer there. Okay, moving on. So it's very similar to the previous exercise, the rest of it. And electrician charges $50 for service call and $6 an hour for labor. Okay, complete the table of values. So this time they have not given you an equation, but they have given you, they've described it. So electrician charges $50 for a service call and $60 an hour for labor. So $60 an hour depends on hours, and $50 is a flat rate. For the electrician to come to your house, this electrician is going to charge you $50. Regardless of if he comes for a minute or an hour or 10 hours, you always get charged $50. And on top of that, you also have to pay $60 an hour per hour that the electrician stays. So if the electrician comes to your house and doesn't spend any hours, you still have to spend you still have to give him $50 per whatever. And you have to give the electrician $50. But if the electrician comes to your house for 1 hour, you have to pay $50 plus the $60 per hour. So it's going to be, look, you know what? We can make an equation out of this. So we're going to say cost is going to equal to $6 an hour. So $60 per hour. Hour is N, number of hours is N, 60N, plus the $50 that you pay all the time. $50 you pay all the time. And now we can simply use our calculator. So let's sub in 1 for N. So when you have 60, open bracket, and here's a quick tip. It's going to help you a lot when you're doing a table of values. So what we're going to do now is we're going to use ants anytime you have the variable. So you know how that's N. N is going to be ants. Okay. So what I'm going to do is I'm going to write 60 ants instead of N. I'm going to write 60 ants plus 50. I'm just going to press equals and ignore that for the time being. What I'm going to do now is I'm going to say, well, I'm trying to sub in N equals to 1. So I'll write 1 equals. Okay. And then now this is answer. If I wipe everything off and I write answer equals, answer is 1 because that's the last answer we got. So now I can go back to this equation. And I press equals, and it's going to sub in 1 because the last answer I got was 1. So in effect, I'm going to do 60 times 1 plus 50, which is 110. And so I can write 110. And the cool thing now is that when I want to sub in 2, I write 2 equals. Now answer is 2 because the last answer I got is 2. So I can go back to my equation, press equals, and it'll sub in 2 now. It's 170. And to do it a lot more quickly, to show you the power of it, you are 3 equals, upstairs equals 230. And 4 equals, upstairs equals 290. So it saves a lot of time. And look, if you don't do it the old way because you don't really understand this, in maths, never use something you don't understand. So I'm going to be putting this up on YouTube. You can pause it, go back, make sure you listen to it again, make sure you really understand it if you're going to use this trick. If you want to avoid it, you don't understand it, you want to avoid it, you want to do it the old the old substitution way, you're more than welcome to. And this is how you do it the old way. So we know that's that. I'm going to sub in N equals to 5. So C is equal to 60. And I'm going to sub in 5 here plus 50. And I'm just going to put that on my calculator. So I can put 60, open bracket, 5, close bracket, plus 50. And that will give you the answer as well, 350. So whichever method you understand and you're comfortable with. Anyway, so you get that. And now it says, yes.
But you know how there's a pattern? If you see a pattern, can you just skip it and write like what the pattern goes in, like what order?
Yep, it's going up by 60s. Is that the pattern you mean?
Yeah, say like you can tell it's going up by 60s. Can you skip?
Yeah, sure, go for it.
And just write, yeah. All right.
Okay, so now the thing with the patterns is something you need to understand on a fundamental level, right? Straight lines have a pattern. That pattern that you're noticing, that's called the gradient. We haven't covered the gradient yet. That's why I'm not mentioning the pattern. But yeah, look, if you notice a pattern, like for example, over here, the number is going up by 60, 50 plus 6 is 110, 110 plus 60 is 170, then it's 230, 290, and it's going up by 60 each time. It's because of $60 an hour. And maybe you've learned this previous years, the coefficient of the variable, what the number next to the letter, that's how much it's going to go up by always. That's the pattern. But look, I don't want to complicate it too much. We are doing just table of values. So to answer your question very simply, if you notice a pattern, more than welcome to fill it in using the pattern. Anyway, so it's a plot a graph of cost against number of hours. So now we're just going to plot it in. So 0, 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. And then you have, now you have to choose a scale. So for the sake of simplicity, I'm going to choose going up by 50. And then I'll just plot the dots in, accordingly. So 50, 100, 150, 200, 250. So 50, 100, 150, 200, 250. And then now I'm going to plot my dots in based on the axis I've chosen. Remember to do the arrows and make sure you put in the N and the C in dollars. It's a good habit to just write the units as well. N hours, C is dollars, cost is in dollars. Now I'm going to plot it in. 0 is 50, 0, 50. First dot goes there. Second dot is at 110, not there, slightly above, around over there. 2 is at 170, so 2 will be roughly around over here. Let's say 3 is going to be 230. Look, if you have a textbook and then you have lines ruled and so on, and using a ruler, this will be a lot neater. Anyway, 3 is at 230, so maybe around over there, I'd say. And 4 is at 290. And look, I made a mistake because my axis doesn't go up enough. And the good thing about doing it digitally is that I can adjust. Sorry. Okay, so what do we have? Up to 350. I thought 250 for some reason. Okay, so we have 250, 300, 350. And this is cost. That's in dollars. I have to write 300 here, 350 there, and look. So it doesn't look blank. I'll just write that in as well. Anyway, 290, then 350. Going back to my red pen. 4 is at 290, so maybe roughly around over there. And 5 is at 350, so roughly there. Now I will join up the lines. Like that. All right, and use the graph to determine the cost of 4.5 hours work and how long the electrician worked for $26. Look, this is basically the same as what we did yesterday. I'm going to stop there. I don't want to make the video too long. I'm sure you can do these. So yeah, just get started with the work, do the questions as marked in the textbook, and yeah, best of luck.